This is a recording from the Kinetic, Potential, and Mechanical Energy worksheet. Number 1, a car travels at a speed of 60 meters per second and has a mass of 1,005 kilograms. What is the kinetic energy? Well, we know the kinetic energy formula is kinetic energy is 1/2 mass times velocity squared. And we know we are given the velocity and we are given the mass. So all we have to do is multiply 1/2 times the mass, which is 1,005, times the velocity squared, which is 60 squared. And what you'll get is 1,809,000 joules. For the second one, a quarterback throws a football weighing 20.5 kilograms at a speed of 10 meters per second at a height of 20 meters. What is the football's mechanical energy? So I'll go ahead and identify all of our variables. Our mass we know is 20.5 kilograms. We know that our velocity is 10 meters per second. Our height is 20 meters. And gravity on Earth is 9.8 meters per second squared. So the first step is we need to solve for both kinetic and potential energy. So first I'm going to solve for kinetic energy. And we know that kinetic energy is 1/2 mass times velocity squared. So all we have to do is multiply 1/2 by 20.5 kilograms times the velocity squared. And when you multiply those three variables together, you will get a kinetic energy of 1,025 joules. Now for the next step, we need to solve for potential energy. And we know potential energy is equal to the mass times gravity times height. We know that the mass is 20.5 kilograms. We know that gravity is 9.8. And we know that the height is 20 meters. When you multiply those three numbers all the way through, you will get a potential energy of 4,018 joules. Now for the last part of this problem, all you have to do is solve for mechanical energy. And you know that mechanical energy is equal to potential energy plus kinetic energy. So all you have to do is add 1,025 plus 4,018, and you will get a whopping mechanical energy of 5,043 joules. Now this one you're going to have to do a little bit of equation reordering because it's looking for the velocity. So a truck weighing 12,000 kilograms has 91,000 joules of kinetic energy. What velocity is it traveling at? Now because we're given kinetic energy, we're going to use the kinetic energy formula, which is kinetic energy is equal to 1/2 mass times velocity squared. And let's identify our variables. We know that the mass is 12,000 kilograms. We know that the kinetic energy is 91,000 joules. But we don't know the velocity, and that's what we need to solve for. So because it is kinetic energy equals 1/2 mass times velocity squared, we know kinetic energy needs to be on this side. So 91,000 is equal to 1/2, that's not going to change, times the mass, which is 12,000, times velocity squared. So the first thing we have to do is we need to multiply these two numbers together. And you're going to get 6,000 times velocity squared is equal to 91,000. To get rid of this 6,000, we have to divide. Divide. This side will cancel out. That will divide. And then what we will be left with is 15.17 is equal to velocity squared. We're almost done. We need to get rid of this exponent though, because this doesn't give us the velocity, this gives us the velocity squared. So if you square root either side, you will be left with v on this side and 3.89 meters per second on this side. All right, similar idea. We're going to solve for the mass this time though. A van travels at a speed of 40 meters per second. with a kinetic energy of 7,600 joules. What is the van's mass? So we are told that it's kinetic energy. So kinetic energy is equal to 1/2 mass times velocity squared. And we know that the kinetic energy is 7,600. So all you have to do is 7,600 is equal to 1/2 times some unknown mass times 40 squared. So first, let's simplify this. This isn't going to change. 7,600 is equal to 1/2 mass times 1,600. And then what we can do to simplify this is multiply 1,600 by 1/2. So we end up getting 7,600 is equal to 800 times n. Now it's just a simple algebra problem. So all you have to do, divide by 800, divide by 800, and you will get a mass of 9.5 kilograms. Alrighty, last one on this page. A hammer weighing 2 kilograms is raised 3.0 meters above the ground. What is its potential energy? So first things first, let's identify the variables. We know that the mass is 2 kilograms. We know that the height is 3 meters. But we also know, because this is potential energy, that the gravity on Earth is 9.8 meters per second squared. We know that the formula is potential energy is equal to mass times gravity times height. So all we have to do is plug this in. The mass is 2 kilograms. The gravity is 9.8. And the height is 3. When you multiply 2 by 9.8 times 3, you will get a potential energy of 58.8 joules. Alrighty. For number 6, you guys really overthought this. All I'm asking you to do is find the kinetic energy of each car. Okay, so let's go ahead and do this. Car 1, 4-cylinder. This one is the 6-cylinder. And remember, the kinetic energy formula is kinetic energy is equal to 1/2 mass times velocity squared. So a 4-cylinder Toyota can reach a maximum of 150 meters per second. So the velocity is 150 meters per second. While a 6-cylinder Toyota can reach a maximum of 180 meters per second. So the velocity is 180 meters per second. If they both weigh 1,500 kilograms, what is the maximum kinetic energy? So we know here the mass is 1,500. Mass is 1,500. Now it's just plugging that into that equation. So all we have to do is kinetic energy is equal to 1/2 times the mass, which is 1,500, times the velocity squared, which is 150 squared. When you multiply that all the way through, if you guys would like to see how I do it on my calculator, 150 squared is equal to 22,500. Multiply that by 0.5. Multiply that by 1,500. And you will get a kinetic energy of 1,687,000. 16 million. I apologize. 16,875,000 joules. So that's one option. This one, we're going to do the exact same thing. Kinetic energy is equal to 1/2. The mass will be the same, but the velocity is going to be 180 squared this time. When you multiply that all the way through, you will get a kinetic energy of 24,300,000 joules. That's all you had to do for that one. Number 7. A ball is raised 5 meters off the ground and weighs 0.75 kilograms. What is its potential energy? So we know that potential energy is equal to mass times gravity times height. So all we have to do is potential energy is equal to 0.75 kilograms times 9.8, the acceleration of Earth, times 5 meters. And in turn, you will get a potential energy of 36.75 joules. Alrighty, number 8. A javelin is raised 10 meters off the ground and has a potential energy of 501 joules. What is the mass? So we know potential energy is equal to mass times gravity times height. And we don't know the mass, but we do know that gravity is equal to 9.8. We know that the potential energy is 501, and we know the height is 10. So all we have to do, guys, is potential energy, which is 501 joules, is equal to some unknown mass times 9.8 times 10. And what you'll do is you'll multiply these two numbers together, and you'll get 98 times m is equal to 501. To get m by itself, you need to divide by 98 on both sides. And you will be left with a potential energy of 5.11 joules. All right, for this next problem, it's also asking for mechanical energy. So once again, you'll have to solve for potential kinetic first. A car has a speed of 0.9 meters per second and a mass of 7,000 kilograms and is driving up a 20-meter hill. What is its mechanical energy? Let's identify our variables first. First, the velocity is 0.9 meters per second. The mass is 7,000 kilograms. The height is 20 meters. And gravity of Earth is 9.8 meters per second squared. So first, let's solve for kinetic energy. We know that kinetic energy is equal to 1/2 mass times velocity squared. So all we have to do here is multiply 1/2 times the mass, which is 7,000 kilograms, times the velocity, which is 0.9, but we need to square that. And what you'll get is a kinetic energy of 2,835 joules. That's part 1. Part 2, we're going to solve for potential energy. And that equation is potential energy is equal to mass times gravity times height. So all we need to do is multiply the mass, which is 7,000, times gravity, which is 9.8, times the height, which is 20 meters. And when you multiply that all the way through, you will get a potential energy of 1,372,000 joules. Now the last and final step is solving for mechanical energy. And mechanical energy, as we know, is potential energy plus kinetic energy. So all we have to do is add these two numbers together. And you will get a total of 1,374,835 joules. All right, last page. Let's zoom this in a little bit. A rock weighs 4 kilograms and has the potential energy of 120 joules. What height is it found at? So we know that the mass is 4 kilograms. We know that gravity is 9.8 meters per second squared. We know that potential energy is 120 joules. And we know that we're going to have to use the potential energy formula. And that is potential energy is equal to mass times gravity times height. So all you need to do is you need to multiply those numbers together. We know potential energy is 120. So 120 is equal to the mass, which is 4 kilograms, times gravity, which is 9.8, times some unknown height. So the first thing we're going to do is we're going to multiply these together. And this side's not going to change. It's going to be 120 is equal to 39.2 times h. How do we get h by itself? We need to divide it. So divided by 39.2, divided by 39.2. This side will cancel out, and we will be left with 3.06 meters is equal to height. For number 11, it's asking the crane carries a metal tube weighing 95 kilograms, 9.0 meters above the ground at a speed of 2.0 meters per second. What is the mechanical energy? So first, let's identify our variables. We have a mass of 95 kilograms. We have a height of 9 meters. We have a velocity of 2 meters per second. And we have a gravity of 9.8 meters per second squared. So first, let's solve for kinetic energy. Kinetic energy is equal to 1/2 mass times velocity squared. So all you have to do is plug these numbers in. 1/2 times 95 times the velocity, which is 2 squared. When you multiply those three numbers together, you'll get a kinetic energy of 190 joules. So we're step 1 done. Step 2, we're going to solve for potential energy. And potential energy is equal to mass times gravity times height. So all you need to do is 95 kilograms times 9.8 meters per second squared times 9 meters. And you will get a potential energy of 8,379 joules. Remember, for the last step, we have number 3. Mechanical energy is equal to potential energy plus kinetic energy. So all you have to do is add 190 plus 8,379, and you will get a total of 8,569 joules of mechanical energy. All right, last one. Tiger Woods is very upset about all of his professional problems, and he decides to go golfing to release his pent-up anger. He hits a golf ball weighing 0.04 kilograms at a speed of 4 meters per second and reaches a height of 30 meters. What is the mechanical energy? So the first thing we have to do, we can't solve for potential energy yet because we don't know. Well, we could, because we know gravity is also 9.8 meters per second squared. But I'm first going to solve for kinetic energy. And kinetic energy is 1/2 mass times velocity squared. So all you have to do is multiply 1/2 times the mass, which is 0.04, times the velocity, which is 4 squared. And you will get a kinetic energy of 0.32 joules. For the second part, you're going to solve for potential energy. Potential energy is mass times gravity times height. So you're going to multiply 0.04 times gravity, which is 9.8, times 30, which is the height. And you will get a potential energy then of 11.76 joules. Last and final step that you're going to be doing is number 3, which is the mechanical energy, which all that is the kinetic energy plus the potential energy. So you're going to add 0.32 plus 11.76, and you will get a whopping 1,208 joules of mechanical energy. I hope this helps.